Hello everyone, welcome to lesson 323 day 2. We're going to talk more about multiplying and dividing rational expressions. Alright, so our goals today, we want to learn how to multiply and divide rational expressions just like we did yesterday, but we're going to throw in a little bit of factoring. So we've talked about this before with the fractions where sometimes being in a factored form allows us to simplify easier than if we were not. So we're going to see some examples where we get to factor. All right, and we're still going to identify excluded values for rational expressions that have been multiplied or divided. Okay, so these first couple of problems are a recap from yesterday. All right, so you'll notice here that we have two rational expressions being multiplied. So you want to make sure that you pay attention to that symbol in between the two fractions here. And since we are multiplying, we can just multiply straight across the top and straight across the bottom. So I always like to think of it as bridging this little gap right here. So it's like it combines to be one big fraction. So we've got 2x plus 7 times x plus 2 all over x plus 2 and x minus 1. Right, so it's like they just combined through multiplication. These things are all being multiplied, which is a good thing because when things are being multiplied, those are factors. And if we have a common factor in the top and in the bottom, we can cancel those out. So I look at the top, I see a 2x plus 7. Then I look in the bottom. I do not see a 2x plus 7 down here, so 2x plus 7 is not going to cancel with anything down here. I see an x plus 2 in the top, so I look in the bottom, and there's an x plus 2 here, so this x plus 2 and this x plus 2 can cancel out. And what's left is 2x plus 7 over x minus 1. And you can keep your parentheses around those. Like I said, I'm still seeing students with a tendency to try and cancel things out inside of the factors. Don't do that. Remember, a 2x plus 7 can only cancel out with another 2x plus 7. You cannot cancel out individual parts of the factors. All right, now we've got to figure out our excluded values. What values of x are we not allowed to be? And we have to go back here to before we canceled anything out. You see an x plus 2 and an x minus 1. We have to take each of those factors and set them equal to 0. So I'm going to take x plus 2, set it equal to 0, and I'm going to take x minus 1 and set it equal to 0. And the reason that we do that is because you're not allowed to divide by 0. Dividing by 0 is bad. All right, so we got to find the values that make zeros, and setting them equal to 0 is a way to do that. So in this equation, right, if I drew my line, I would subtract 2 from both sides. They cancel there, and we find that negative 2 would create a 0 in this factor, so we would have to exclude it from our domain. Same thing over here, we would add 1 to both sides, and you would solve and find that x equals positive 1. A positive 1 would make a 0 here, so we have to exclude it from our domain. This is our final answer. This is what we're looking for. This is our simplified rational expression. These are the excluded values. All right, let's try it again for this one. Notice that the sign or the operation in between the two fractions has changed. This is division now. All right, so when we divide, we do a KFC, a keep flip change when we divide fractions. Okay, so we keep the first. So we've got 2x plus 7 over x plus 1. And I'm going to keep my parentheses around those. Right, so I just kept the first. Now I'm going to flip the second, right? So these two are going to switch places. We're flipping them over. So I'm going to have the x plus 2 in the top and a 2x plus 7 in the bottom. And then the C stands for change, so we're going to change to multiplication. Right, so instead of division now, we change to multiplication. So when we do that flip and change to multiplication, it actually keeps it as an equivalent expression to what we started with. All right, so now when I multiply, I can do exactly what I did up here. I can combine these. So I can say 2x plus 7 and x plus 2. And then we have an x plus 1 and a 2x plus 7 in the bottom. And then I scan the top and the bottom for common factors. You'll notice 2x plus 7, those are the same in the top and in the bottom. So I'm going to cancel one set of 2x plus 7's out, And look at what I have left. I have an x plus 2 and an x plus 1. So there's my simplified rational expression, and then I have to go back to here to get my excluded values. So if I take x plus 1 and set it equal to 0, I would solve, and we would find that x equals -1. So x equals -1 has to be excluded from the domain. I cannot allow x to be -1 because it would create a 0 in the bottom of my fraction. Now I have to do the same thing here. I'm going to take 2x plus 7 and set it equal to 0 and solve. Right, so I would subtract 7, those cancel. We get 2x equals -7, and then we would divide by 2. Right, so we find x cannot equal -7 over 2. And I would just write that in as a fraction, just like that. You don't have to get a decimal or anything. But here's our simplified rational expression, and here's our two excluded values. All right. All right, now in our third example, all right, so this one looks a little bit different than the kinds that we've been doing up to this point, and that is because of this guy right here, right? This one is not in its factored form, right? The rest of these, x minus 2 and the x plus 5 and the x minus 5, we can throw those in parentheses, but this one, we can break this down into something that looks like this, right? Where we have two parentheses using our factoring techniques. So I'm going to focus on this bottom expression for right now. I'm going to take this x squared plus 8x plus 15, and I'm going to factor it. So I'm going to set up a box and a diamond real quick. If you are weak on your factoring skills, this is a good opportunity to try and relearn this. Okay, so to factor x squared plus 8x plus 15, we take the x squared term, it goes in the upper left-hand box. The 15 goes in the bottom right. The 8x, or the middle term, goes in the bottom of our diamond. And then we multiply this diagonal to get the top of our diamond. So we do 15 times x squared, which gets me 15x squared. And I'm looking for two numbers that multiply to give me a 15 and add to give me an 8. That's going to be 5x and 3x. So 5 times 3 is 15. 5 plus 3 is 8. So that allows me to fill in my other diagonal. Now I start working on my outside dimensions here, right? So x squared is going to be x and x, right? Because x times x is x squared. And then down here, we're going to have x times 3 to get 3x and x times 5 to get 5x. Okay, so if I'm rewriting this expression, right, the top didn't change, so we have an x minus 2, but the bottom changed into a factored form, right, where I'm going to have x plus 5 and x plus 3. All right, so this x squared plus 8x plus 15 changed to this. And we're still multiplying by x plus 5 over x minus 5. Okay, so remember when we multiply, we can bridge the gap. Right, so we just multiply straight across the top, straight across the bottom. So really we're just pushing these two fractions together. So what we end up with here is x minus 2 times x plus 5 over x plus 5 times x plus 3 times x minus 5. And then we scan the top and the bottom for any common factors. So for instance, the x plus 5s, those can go, right? Those cancel out, they become 1. And all we're left with is x minus 2 in the top and x plus 3 and x minus 5 in the bottom. Now we do need to get our excluded values. We need to figure out what values of x create zeros. So if we look at this first factor, a -5 would create a 0 here, so I need to exclude that one. A -3, right, because -3 plus 3 creates a 0, so I need to get rid of -3. And then here a +5. 5 minus 5 would create a 0. So I'm going to exclude -5, -3, and 5 from my domain. So here's my simplified rational expression. Here are my excluded values. All right, let's try it one more time here. So very similar. The only difference is, right, the operation has changed. Okay, so we are dealing with division, so it means we need to do a keep flip change, and I'm going to do that first. So I'm going to keep the first fraction. So I have x plus 1 over x squared minus 4x minus 5, and then we're going to flip the second, so we've got x minus 5 over x minus 1, and then we change the multiplication. Okay, and I'm going to make sure I put all of these things in parentheses so I'm not tempted to cancel anything out that I shouldn't. And then I want to make sure that I get into factored form here, right? So we have a quadratic, this is called a quadratic trinomial, right? It's in its standard form. We want to put it in its factored form before we go and try and cancel anything out. So I'm going to set up a box and diamond. Okay. So again, the x squared term goes in the upper left-hand corner. The constant on the end goes in the bottom right, and the middle term goes in the bottom of the diamond. I multiply my diagonal to get the top of my diamond, so -5 times x squared is -5x squared, and then I look for two numbers that multiply to -5 and add to -4. Okay, so those numbers are going to be -5x and +1x. -5 times +1 is a -5. -5 plus 1 is a -4. And I can use those numbers to fill in my other diagonal. Then I go and get my outside dimensions. So we'll have x and x to get x squared. X times 1 gets me 1x, and x times -5 gets me -5x. Okay, so I'm going to write an equal sign here, and I'm going to rewrite my expression with the factored form in there. All right, so the top didn't change, so we got x plus 1. And then the x squared minus 4x minus 5 changed to its factored form, like this. All right, so I'm going to have x minus 5 in one, and x plus 1 in the other, times x minus 5 over x minus 1. Okay. And I remember multiplication. Oops. And I remember multiplication essentially tells us to bridge the gap here. Lost my pen. All right, so we're going to bridge the gap and rewrite that with those two fractions combined essentially, right? We're just multiplying, so it's going to be x plus 1 times x minus 5 over, and then we have x minus 5 times x plus 1 times x minus 1. Then you want to scan the top and the bottom and see what will cancel. So I see an x minus 5, those will cancel. I see an x plus 1 in the top and the bottom, so those will cancel, and then we write what's left. Now, this is a common mistake that students will make. You might think, well, these all canceled, so there's nothing left in the top. But remember, when you cancel in a fraction, they cancel to 1. So these big slashes actually represent ones. All right, so there's a 1 in the top, not a 0. And all that's left in the bottom is an x minus 1. Okay, so this becomes our simplified rational expression. We got to go back and get our excluded values. Make sure you go back to here, okay, where you can see all of your factors before they canceled. And we're going to see here 5 minus 5 creates a 0, so we need to exclude 5. -1 plus 1 would create a 0, so we need to exclude -1. And then in the third factor, 1 minus 1 would create a 0, so we also need to exclude +1. There's my final answer. All right, guys, I hope you found those helpful. Let me know if you have questions in the Zoom chat. Have a great day.